This is one variation on the theme of how you might make up solutions that are diluted by a factor of 10. It works a lot easier in terms of students being at ease with the difficult numbers of 1 and 10 if you actually use 10 mil, 10 centimetre cubed. So we've got our stock solution, and I'm very carefully poured in 10 mil of my stock solution, and I know that's my starting point. So that goes then into my first tube, which is that's 1.0, so that's the same as that guy there. Just for illustration purposes, I've marked on the tube where 10 mil comes up to, just so I know roughly how much we're going to be needing. So I have 10 mil of my starting solution. I've got to dilute that by a factor of 10. I could use a pipette, I could use a syringe to take out 1 mil, and this is where you need to just, I suppose, give students a little bit of chance to explore. If I'm going to take 1 mil out of there, it might just about be not quite far enough for that syringe to fit in. It certainly won't work with anything else. It could work with a pipette, but pipette, it's going to go in. But how trustworthy are the measurements on your pipette? So one way would just put your pipette in, take out 1 mil, put it into the next tube, add 9 mil of water, give that a good mix up, and away we go along that particular process. Alternatively, you could you not, pour 1 mil back into the measuring cylinder. I could adjust it very carefully with a pipette so I've got the right amount. Then add 9 mil of water, and I think I might be using either a pipette or a syringe to do that, but just use a syringe to do that. Well, quickly, I'm just going to pour it in. It's been measured wonderfully by a pipette, and I'm going to put that into my next tube and label it up. So that will be 1, that will be 0.1. I need to take out 1 mil of this, and I'm just going to pour it into here for expediency. And oh my goodness, that's just a bit too much. Okay, I've carefully adjusted it with pipette, so it's exactly 1 mil. I've carefully pipetted in 1 mil, 9 more mils of water to make that up to 10. Dun, dun, dun. Well, that's not bad. Into the next tube, so that's 1.1, 0.01. I'll move that away for the time being, and that's the methodology. We're taking 1 mil of the first solution into the second container, in this case test tube, and 9 mil of water, give it a good old shake up so it's fully mixed up. Take 1 mil from the second test tube into the third, add 9 of water, go down as far as the number of dilutions that you're particularly looking for. You can see that they're starting to become quite noticeably different. So, however your students have devised a way of making this dilution factor work, you need to be, and they need to be aware that just look about the potential contamination of all the little dribbles that are knocking around, and if this particular dribble went into one of those solutions further down the line, it's going to make an awful big difference. So good practice washing things out all the way through, washing things out all the way through. So I've got my washing up beaker and swilling that and getting rid of that every now and then and putting some more washing up washing facility. So I'm trying to eradicate the effect of these little dribbles of contamination. That will show you something with a glucose detection, how significant those little drips might be in terms of throwing out all of the results. More about that in a little while.